Coal's quantum leap. Pioneering the future of nanoelectronics. Coal is an abundant resource in the United States that has, unfortunately, contributed to climate change through its use as a fossil fuel. As the country transitions to other means of energy production, it will be important to consider and reevaluate coal's economic role. A joint research effort from the University of Illinois Urbana-Champaign, the National Energy Technology Laboratory, Oak Ridge National Laboratory, and the Taiwan Semiconductor Manufacturing Company, TSMC, has shown how coal can play a vital role in next-generation electronic devices. Coal is usually thought of as something bulky and dirty, but the processing techniques we've developed can transform it into high-purity materials just a couple of atoms thick, said Ching Cao, a U of I materials science and engineering professor and a co-lead of the collaboration. Their unique atomic structures and properties are ideal for making some of the smallest possible electronics with performance superior to state-of-the-art. A process developed by the NETL first converts coal char into nanoscale carbon disks called carbon dots that the U of I research group demonstrated can be connected to form atomically thin membranes for applications in both two-dimensional transistors and memristors, technologies that will be critical to constructing more advanced electronics. These results are reported in the journal Communications Engineering, perfect for 2D electronics. In the ongoing search for smaller, faster and more efficient electronics, the final step will be devices made with materials just 1 or 2 atoms thick. It is impossible for devices to be smaller than this limit, and their small scale often makes them operate much quicker and consume far less energy. While ultra-thin semiconductors have been extensively studied, it is also necessary to have atomically thin insulators, materials that block electric currents to construct working electronic devices like transistors and memristors. Atomically thin layers of carbon with disordered atomic structures can function as an excellent insulator for constructing two-dimensional devices. The researchers in the collaboration have shown that such carbon layers can be formed from carbon dots derived from coal char. To demonstrate their capabilities, the U of I group led by Cao developed 2 examples of two-dimensional devices. It's really quite exciting, because this is the first time that coal, something we normally see as low-tech, has been directly linked to the cutting edge of microelectronics, Cao said. The semiconductor industry, including our collaborators at Taiwan Semiconductor, is very interested in the capabilities of two-dimensional devices, and we're trying to fulfill that promise, Cao said. Over the next few years, the U of I will continue to collaborate with NETL to develop a fabrication process for coal-based carbon insulators that can be implemented in industrial settings.